Hello everyone, welcome back to Dragonfly Engineering. So this week we're continuing the mold build that I started in the previous episode, and this is the part that we're molding. And here we are starting up where we left off, where the blue anodized core is inserted into the base of the mold, and now I'm machining the runner that will emanate from the center of the mold out to 4 points or 4 gates that connect to the rest of the round body. This isn't a tunnel gate, you can see it's just straight gates that break off, unfortunately, after the part is molded. And I will continue with assembling the mold parts that we machined last week. All right, so we made it to final assembly, hopefully, of this mold. So I machined in the runner here on the B-side core. And this core basically just creates the large cylindrical cavity of the part. And then we have over here a stripper plate, which is also blue anodized. The blue doesn't really signify much. It's just a cool color that I could choose from. But we anodize these metal parts because they slide together. So we create kind of a swage joint here. So there's another plate that goes under here, which I will install right now. And then I've got a bunch of these little inserts. These tiny little pin inserts are extremely short ejector pins that fit into these threaded holes that are then going to be capped by some shoulder screws that are the bearings for this sliding plate that slides over this core. And then this plate has some angled surfaces that create a ribbed wall in the part itself. So since there is a few ribbed walls that were kind of blind ribs in this part, like round ribs, I split those rib formations up using this plate. So there's an outer rib and an inner rib, and this plate allows us to push both of those ribs out of a kind of a deep pocket in the cavity of the mold, as well as provide vent paths so that the gas can exit the mold out through parting lines and things, and so the plastic won't trap and compress a pocket of air, and then it can actually fill the part. So let's get the other plate that is going to fit onto this main surface of the mold. And it looks like I've got I need to blow some of these chips out too. I've got some dowel pin holes to align the part. Need a little deburr on this part here. Got a couple of sharp edges. This is the outer ring. It sets the sort of the mounting flange of this plastic part, and also receives the swaged kind of 10-degree angle for the blue sliding stripper plate. All right, so we can drop this plate down. Like so. And then I've got dowel pin holes to align this structure, because everything's got this plate is going to nestle in between the two. So let me grab some 1/4-inch dowel pins and then some 3/8 bolts that will bolt this plate down. Okay, so I put these 1/4-inch dowel pins in these holes, and then I've got 2 more on the bottom of the plate here. And now we will slip these in place. Now line these precision dowel pin holes up. They're not hole and slot like you normally do. So we're going to rely on basically over constraining these dowel pin holes with perfect reamed diameters with basically no designed in tolerance. And then these are going to be a little tight going in, even though each dowel pin in itself would probably fit in just fine, but when you stack them up with no tolerance forgiveness in the assembly of the parts, you wind up with a press fit to a certain degree. So we're going to hammer these down. And just the fact that we've got several precision pin alignment dowel hole pins in concert with each other, they're probably going to be locked in, and the pin can't really come out just because of the over-constrained nature of the assembly. But the plate went down, and that feels good. So so we can move on to bolting our plate down. And those dowel pins help with, mechanical alignment, as well as trying to keep this ring of the mold from kind of pillowing out from the pressure of the injection of the plastic. These 3/8 bolts will help as well. But the pins themselves are probably more of the rigidity structure for the plate to remain in place, as well as the clamp force when the molding machine clamps up on this mold. Just friction itself would help immensely. I'm short one 3/8 bolt, so I'll have to grab another one. Oh, I scratched it right there. The only surface that really matters for anodizing is the wear kind of swage surface right here. This is a 10-degree angle that's going to connect with a 10-degree angle at the base of this post. And that is a sliding action every time the mold opens. So we want to put anodize on both of those surfaces so that it does not basically gall up. All right, then we fit our swage in. Looks like it may be a little tight. Do some convincing. All right. Okay, we're back. So I did have to open up some of the clearance holes in the B-side base such that all of these ejector pins would slide freely. That one's still slightly tight, but I think it'll loosen up. Actually, if I put some lube on it, it'll probably get happy right now. Yeah, usually there's something in these setups that causes you a little trouble. But as you can see, we can raise up the... Actually, I can't even raise it up because most of the ejector pins are nice and clear now. There's one that jammed up a little. So yeah, so our stripper plate, I did have a little bit of interference with some ejector pin holes in the bottom, which I was able to alleviate by opening up some holes in the base. So we can pull these out. Those pins were just used for fit checking. Yeah, I guess it's actually, that one was, I may have to lube that one up a little bit. Oh, anyway. Yeah, so we'll put that aside. And now that I've kind of tested the orientation, I'm going to put an X on both of these plates so that I know how they go back together. Then we can pull this base plate off. I'll re-dowel pin it and bolt it on. But I did unbolt the core from the mold base to drill out a couple of holes. So we can bolt that back into place now. And I had to modify some of these bolts so that they fit. Actually, I gotta clean that out. I'll be right back. Okay, we're back. So this second pocket down here actually allows me a little extra travel for the second ejector plate, which is going to ride on top of the first ejector plate. So the first ejector plate is going to be actuated by the molding machine, and the second ejector plate is going to be actuated by this pancake air cylinder is what they're called. And it will sit basically in the cavity of the first ejector plate. Okay, so the blue core is still in the back here, or in the front, so I am going to bolt it in place. And these bolt holes are a little bit of a tight fit just because there's a label, a text label machined into the core. And I wanted to make sure that that text is visually oriented correctly. It doesn't need to be within a thousandths, but it needs to look square to a person looking at the part. So this is a little bit of a tight fit by design. Whoops. so I get full swing on my hex drive here. Could be these dowel pins are just not going to work out. I think there's too many conflicts of dimensions. So I'm going to pull those out. Hopefully this metal ring has enough force to hold itself in place. I guess I can always, after everything's assembled, turn down these dowel pins and then fit them in place. Yeah, because right now the part is kind of locked up on these dowel pins. So I probably do have a couple of thousandths of asymmetry or something, which caused that key which is the kind of needs to be an interference fit, to not fully seat. And this, happens with molds. You can't expect to have every single part or your tire tolerance stack up be less than 1/1000th of an inch. So let's pull these 2 other dowel pins out, and I will have to probably get undersized dowel pins or turn those down and then do the final fit that way. In fact, there's these other 2 dowel pins on this side. Yeah, there's just too many moving parts that need to nestle, so we almost have to custom fit these parts together. So let's bring this guy back down. Our X is over here, which may update actually as we explore how this all goes together. And we put our stripper ring in. Help if I put it in right side up. I wonder if that was the issue. Did I have it upside down? Actually, I'm going to try to stick a dowel pin back in through the top of the hole and see if it will seat. It felt like it did something there. Well, let's go ahead and bolt it down, and we'll deal with the dowel pins after the fact, because the main point of interest is that our stripper plate is concentric to the inner seal flange and the outer seal flange, which is on this aluminum square ring. Sometimes you just got to get the mold together and then figure it out after the fact. I've got a few more bolts here, which I need to figure out where they went. Hey, quiet. Then you bolt the pipe start, then you chase it out with the tap, and fix the 2000s, offset the 2000, so you can start that. So now the next step is to stick our little dowel pin inserts into this stripper plate. So let's see if I can pop this guy out. These pins go in the back way, so those all have to come out as well. And then I've got these tiny little pins. Maybe able to see that. Just to cut off 1/16 ejector pin. All right, we will stick into these tiny holes right there. And then the shoulder bolts will cap those into place and also set the, okay, and then we can set this guy, making sure we're clean in there. Yeah, and this plate has like 2 tapered faces, so there's no square edges on this thing, which adds to the complexity of the precision of it, because you don't want perpendicular or parallel surfaces sliding on each other in a mold or any mechanism, because they'll gall up and jam up pretty quickly. So everything is like triangular joints that come together and release like that. Okay, it's in there. So we'll spin everything around to the back. So now I need to string in the top of the ejector plate, the main ejector plate, which means I need the return pins. And these all have a keyway of a particular orientation. Because we got to put our second ejector plate in first, which means all the ejector pins need to go into this ejector plate now. So this is going to be the air piston actuated ejector. So we'll slide all this back, and then we'll open this thing up and stick all of our pins in. This thing's going to be a little complicated. Oh, and I got to stick the other 2 bearings in too. Let me get those. I got some linear plane bearings here with kind of a tight fit. Not too bad, but they also are nice for keeping your 2 plates aligned. This is, again, the second ejection plate. So now the question is, can we take this plate off without randomly drifting our bearings from one side to the other? There we go. Okay. So now we stick all of our ejector pins in the secondary ejector plate, and I'm going to have to grind some of the heads around these linear bearings because they overlap currently. But that's easy to do. I'll probably just do that off camera. Yeah, so I pushed these bearings down past the second plate so that I could take the thing apart. I tried shoving like a file, or not a file, but a chisel in there, but it just wasn't working. And then I realized I can just drift the bearings forward and solve the problem. All right, so I need to face off this seat so that we're clearing the bearing when we push it back up through. So I'll do that on the grinder off camera. Just grinding off kind of the edge of this foot here. Oh, actually, I probably need to I gotta drill out some of that bearing too, unfortunately. Okay, we'll do that next. I wonder if I should just, no, I gotta drill it out. Okay, we can go over to the manual mill and I will face off the sides of these bearings so that we clear our 1/4 inch ejector pin. Okay. That one got a little carried away. Guess I probably didn't have to grind these after all, but it doesn't hurt to have redundancy and clearance, and it was quick and easy. Okay. So we get our pins. Usually you find something that's not right, no matter how much you design, and then you gotta fix it on the fly. Okay. Now we can put our back plate back on with our tubing access for the air cylinder. All right, we can screw this back together. Might as well screw on the air cylinder now too. We're using a 3-inch air cylinder, what is it? It's an air cylinder, I think it's a 2-inch, and it can create 350 pounds of force to do the secondary ejection to strip the part off of the stripper plate. Here's a bolt that screws our air cylinder onto the back, and this is our air cylinder. In fact, I need to put the air fitting in it now. So this is a push to connect plastic air fitting. And this is called a pancake cylinder, air cylinder. And this thing pushes out by about 15 millimeters or 5/8 of an inch. A little redundant Teflon tape on here, because this thing's gonna be hard to get to once we build this mold. And we might as well connect our tubing as well. All right, so green will be go, which means eject. So we'll put green on the bottom, and blue will be the return, even though that's, I guess red would have been a more appropriate color, but I'm low on that. Yeah, and you just push this tubing in. Sometimes the metric versus the English, or the 6 millimeters versus the 6.35, which is 1/4 inch. Sometimes you can make those work, but sometimes they also leak. Okay. So now we can see if we can stage this correctly. I don't really have access to grab onto this shaft once I start screwing it in. So I may have to come back later and actually Loctite this or glue this thread in. But this is going to be the first run prototype, so I don't think it's going to fail for the first 30 parts or so. I'm sure there's going to be something else that needs to be updated on this. But this air cylinder is the second ejector. After the first ejector is the molding machine pushing on the main ejector plate for this mold. I need to get the screw. So I modified this flathead screw to basically fit, because I didn't have a countersink tool with a big enough diameter to actually create a perfect countersink here. Oh, it's tightening up pretty good, actually. That's surprising. Something actually going our way. Oh, now I feel the cylinder spinning in its body. Well, I'm still getting a bite and I can tighten it. So, all All right, that's what we got. So now this cylinder is going to push in and out and give us a little extra ejection off of our stripper plate as the secondary ejection. The molding machine will basically supply air to this cylinder like half a second after it ejects the main stripper plate forward. And now, well, there's a lot of sequences that I need to get right here. So now I need to pound these bearings back so that they fit, or that they're flush to the bottom. And keep the line. Okay. And then we need this. Let's see, these notches here are going to clear a pedestal. Dog, be quiet. So I think let's go ahead and stick these through. But we don't want to push off our stripper plate because we also need to bolt them. All right, so our stripper plate is here, teetering on our core with our pins in there. And then we will push these pins through. Oh, I probably should have. I guess we can go all the way forward. Nope, see, I'm off. This needs to rotate this way so that so we clear our pedestals. These molds sure get complicated. Okay, so our second stripper plate is in the back now, like so. Now we can spin this guy around, and I need to make sure that our little dowel pins are still happy in their pockets. And they are. And now I will attempt to string all of these secondary ejector pins on through our stripper plate. And I didn't chamfer these, so this may be a little challenging. And I may actually have to wind up chamfering this. So we'll see. Or I gotta, well, it's gonna be a hassle to unbolt that plate with all the bearings in it. But this may not be possible. So I think I will chamfer the backs of these holes to give me a little bit of a cheat, so I can get every pin lined up with a perfect precision reamed hole. All right, so here's our little lead-in chamfers. Maybe that's enough to help us simultaneously align all 12 of these pins. It's still going to be a little tricky operation, I think. Get the top started. If I can tap it. Nope. All right, sit down. These are fall. All good. You'll put your All right, so I was a little perplexed why I was jamming up on this stripper plate, so I took the second ejector plate and the stripper plate out of the mold, and I reset the pinch, or basically the clamping of the ejector pins with this bottom plate. And the way I did that is I pushed the stripper plate all the way down, or as close as I could, and then I went and I loosened up all of the nuts, or the bolts back here, and that allows each pin, with the little bit of slop that I added in the receivers for the backs of these ejector pins, which has basically a foot, you know, like a much smaller version of this foot inside of here. What I wound up doing is, you know, when I designed this part, I allocated some assembly slop for this very reason, you know, you can't get everything exactly perfect and expect it to move freely. But you can loosen up everything and then let the plate go all the way to the bottom, and that basically sets the ideal position of all of our ejector pins as they sit inside of their little referenced pocket. And then you go back and you retighten all these, and you're setting the perfect bearing position for all these ejector pins at the base. But as the pins move away from the base, they can flex a little bit and be a little more forgiving. That's why after I retightened everything, I couldn't quite get the stripper plate to the bottom. But the stripper plate's only going to be traveling at the end of these pins, so it's not a huge deal. So now it'll probably be a little tight down here at the bottom, but then when I come up to the top, I can move the stripper plate a lot more freely, like so. I still can't grab it from one side because it is angle locking, but if I support both or just 2 points on this stripper plate, then I can get it to move up and down. So, and it's pretty free. It's actually falling under its own weight. And then when we add the framework with these shoulder bolts and the bearings here, it should lock the angle in better so that we can actuate more freely. Because let's see, is that right? Each one of these bolts is going to push on a corner. So just by me pushing lightly on one corner at a time, we can actuate it without it jamming up. But we're going to have 4 corners pushing on it. Now, as the pins leave the top, then a different phenomenon occurs and they angle lock just because the pin is kind of jamming up in its hole. But when you get back into full cylindrical bearing, then we're back to moving freely. So that's good to see. This plate through here, like so. And then we need to realign our stripper plate with the letter down and do the tricky maneuver of lining up all these pins, which should be easier now. All right, well, I chamfered the back of the holes a little more with a 60-degree chamfer tool. Or sorry, a 30-degree, they call it 30. But, and this really helped with a countersink tool, a 30-degree countersink. And that helped guide the pins in a lot easier. I also loosened up the back. So I think we are finally good on fitment, knock on wood. So there we are with the stripper plate, and it's sliding easily, installed in the mold. So that's good. Now I'm going to tighten up this back plate with the stripper plate fully seated. Oh yeah, it's going to be nice and difficult. Maximum difficulty. These springs don't do very much. They're not die springs, but they probably will help slightly with keeping the ejector plate from racking too much, because it does put coaxial stabilization force on these return pins. But kind of very little. All right, there we go. Oh, yeah, then I connect the final hose in the back port now. Right there is our new hose location. I might have to do a tape. All right. So reconnect our green hose. Like that. I'll have to tape that too. I'll get better tape later. Alright, well, not bad. There's still some stuff I gotta fix on it. Ejector pins are too high for some reason. Maybe not. Okay, I'm going to hook the air compressor up to the piston to see how we do the second ejection. The first ejection is done by the molding machine, which will push this stripper plate up. And then the second ejection is going to be simulated with our air hose, 100 PSI, and the green tube, which means go. So let's see what happens. Look at that. That looks nice. That way we eject the part off that's stuck on the stripper plate. So we got a two-stage ejection here. So hopefully these will retract when I hit the blue button. Not quite. All right, got to work on that. I think I forgot to bolt the, I didn't bolt the piston to the base. That'll do it. So yeah, the problem is there's no screws there to hold the piston, or to hold the piston in place while it pulls the ejector plate back. So we I think we're set. That wasn't so hard, now was it? Let's try that again. So green is go. There's our second ejection. Keep in mind this plate will be lifted up and then these pins move with the plate, and then we'll eject as a second shot, or a second stage ejection. And now we're going to retract them. Okay, we are set. Yeesh, I'm going to go home.